Welcome viewers. I welcome you all to our YouTube channel mathsdiscussion.com. So today in this video we are going to look into one of the very important concept of complex number, that is concept of rotation. Concept of rotation is, in a way you can say, is the interpretation, the geometrical interpretation of the multiplication of a complex number by another complex number, which is e power I alpha, where alpha is the angle of rotation. Do not forget to subscribe to our channel. Not only subscribe it, also like it and share it to your friends so that they also get the benefit of the mathsdiscussion.com. And most important thing, do select the bell icon so that whenever we upload any new video on similar content on mathematics, you will be getting the immediate notification for that. Now let us look into geometrically what happens when we multiply a complex number with another complex number. We have seen earlier that when we multiply the two complex number, the property of the modulus is the magnitude get multiplied and that of argument is arguments get added up. So using the same, let us say we have a complex number represented by the point A on argand plane, that is z is equal to r e power I theta, is a non-zero complex number where r is the modulus of z and theta is the argument of the complex number z. Now what will happen if I multiply this complex number z with e power I alpha? So going by the property of the multiplication of the complex number, we can say that z into e power I alpha will be nothing but r into e power iota alpha plus theta. Let us say that is a new complex number w. So if I talk about what is the distance of w from the origin, is same as r only, and w represent a complex number which is nothing but z into e power I alpha, but the argument of w is nothing but theta plus alpha because the arguments get added up. So geometrically you can see that the complex number w, what we have got on the argand plane, which is represented by z into e power I alpha, is simply we can obtain this complex number if I rotate my line segment OA about the origin by an angle alpha. That means if I am multiplying a complex number with a unimodular complex number e power I alpha, then we get a point on the argand plane which represent the rotation of line joining that point A to the origin by an angle alpha in the anti-clockwise direction if alpha is positive, will be clockwise direction if alpha is negative. So that is how we can represent the rotation of the complex number. Now keeping this thing into mind, let us say you have got two complex number on argand plane. One is represented by the point A, that is z1, and point B, z2, such that z1 is r1 e power I theta 1, that means magnitude or modulus of z1 is r1 and argument is theta 1, and z2 is another complex number which is at a distance of r2 from origin, that is modulus of z2 is r2 and the argument is theta 2. And let us say the angle AOB, which is theta 2 minus theta 1, is alpha. In that case, keeping the same concept of multiplication of the complex number into mind, we can write the new position, that is complex number z2, as if I rotate my line segment OA about origin, and let us say I maintain the distance of OA, only thing is I bring that in the direction of OB, will be I will be multiplying z1 with the complex number e power I alpha. Now once you multiply with the complex number e power I alpha, you will get a point which is represented by, let us say, some complex number a dash, which is z1 into e power I alpha on OB. Now I want the distance of this point B from origin should be equal to r2, whereas distance of O dash a dash from origin is nothing but r1. So what we do is we multiply now this z1 into e power I alpha with a ratio of r2 by r1. So that will give us the complex number z2, which is nothing but r2 by r1 into z1 into e power I alpha. Or we can also write this as z2 upon z1 is equal to r2 upon r1 into e power I alpha, where R2 and R1 are also the modulus of the complex number Z2 and Z1. Now this is what we call it as the concept of rotation. That is, if I rotate my line segment OA about origin by an angle alpha such that after rotation the new position of the complex number is nothing but Z2, then you can say that the final position after rotation upon the initial position before rotation is equal to the distance of the final position from the origin divided by the distance of the initial position from the origin into e per iota the angle of rotation. So this gives us the concept of rotation about the origin. In the same way, we can also talk about the rotation about some other point, let us say P of Z0 on the Argand plane. I take a point P of Z0 and there is a complex number A of Z1 and A of Z2. Now if I rotate line segment PA about the point P by an angle alpha. So how we can do this is, what will happen is if I shift my origin to the point P, then with respect to the new Argand plane, the complex number represented by the point A will become Z1 minus Z0, represented by the point B will become Z2 minus Z0. Now it is the case of the rotation about the origin. So going by the same rule, final position, that is Z2 minus Z0 upon the initial position, that is Z1 minus Z0, is equal to the distance of point B from P, that is modulus of Z2 minus Z0, divided by distance of point A from P, that is Z1 minus Z0, into e per iota the angle of rotation. So this gives us the concept of rotation. Here Z2 is the new position after rotation, Z1 is the initial position, and rotation is about the point P of Z0. So this is how we can understand the simple concept of multiplication is nothing but the concept of rotation. Now on the application of this, the different types of questions, you can visit to our website, that is www.mathsdiscussion.com. In that you can look into the 11th class topics in that complex number. If you have got any other doubt, you can also put into our discussion forum in that website. And finally, how do you find our video? Do write in the comment box what you liked or what you did not like into the video. And one of the biggest advantage of mathsdiscussion.com is we also have a website in which we have got a discussion forum. You can register into our website. The website address is www.mathsdiscussion.com. There you register yourself with your email ID and create your user. Whatever you want to ask either on this topic or any other topic of your interest, you can put a question into that and discuss whatever the doubts you got. And don't forget to write your comments into the comment box so that we will give a reply on to that. And anything new what you want in these videos, do write it to the comment box so that we try to incorporate that into our future. And once again, I request all of you to subscribe to our channel and share it with your friends so that they also get the benefit of mathsdiscussion.com. And thank you.